So we've got to go over v equals d over t, okay? Using it to solve questions, sometimes questions that have like multiple steps. So what we need to first look at is the manipulation. Just a quick kind of review of algebra, and then we're going to talk about how this can also mean average velocity is total displacement over total time. We're talking about a trip with multiple parts. Okay? So first off, manipulating v equals d over t. If I want to get d by itself, what do I do? Right, multiply both sides by t, right? Rules of algebra are if you want to do something, if you want to move something, you do the opposite operation. What you do to one side, you do to the other. And you move what's not attached to what you're looking for first, which won't apply to this because everything is attached in this one. All right, so I want to move t over to the other side. Okay, so I multiply both sides by t. T times v equals d. Everybody all right with that? Okay. If I'm starting over here again and I want to get t by itself, what do I do? Okay, if I multiply d here, I'm going to have d times d. That's going to give me d squared. Okay, and that's our natural instinct is, well, I need to leave t over here by itself, so I have to move d. But in actual fact, t is on the bottom of this equation. If I move d over by dividing it, I would be left with 1 over t. Is that the same as t? It's not, okay? Because 2 is not the same as 1 over 2. Agreed? Those are very different. Okay? So if I want to get t by itself, the first thing I need to do is move it over to the other side, like I did a minute ago, and then take v down to the other side by dividing it. All right? We always want to solve for something when it's sitting on the top of an equation. Right? We don't want to solve for 1 over that thing, we want to solve for that thing, and that's what we have to do there. All right? Making sense to everybody? All right. If I have a situation where I've got a trip, or a question that's talking about a trip that has more than one part, so it's not just as simple as it went this far in this amount of time, calculate v. It's now, first part of this trip, it went this fast for this long, and in the second part of this trip, it went this far at this speed. Calculate the average velocity. Okay, well now I've got a trip containing 2 parts. Okay, and now I need to use this formula in its other alteration. That would be that average speed, or average velocity, okay, is equal to the total displacement over the total time. So what that means is I need to know the displacement in each part of the trip and the time for each part of the trip. Okay? It's not as simple as, oh, I know the velocity in part 1 and the velocity in part 2. I'll just add them together and divide by 2 because that's how I got taught to do averages when I was 12. Okay? Why won't that work? Why won't adding the 2 averages, or adding the 2 velocities together, dividing by 2, get you the average velocity? There's only one situation where it would work. The other 99% of them it would fail. Okay, let me put it to you a different way. Let's say I drive all the way to Edmonton. Okay, and if you know your geography, let's say I drive all the way to Leduc, which is like 20 minutes south of Edmonton. Okay, I drive all the way to Leduc at 120 kilometers an hour. When I get to Leduc, there's a section of construction from Leduc to Edmonton where I can only travel 50 kilometers per hour. Okay? Is my average speed going to be 120 plus 50 divided by 2? Absolutely not. I did most of the trip at 120. My average velocity is much closer to 120 than it is to 50, and it's certainly not halfway in between because I have to weight the average. Okay? I have to weight it in favor of, I did that for a lot more than I did this little part. All right? That's why we want to do total displacement over total time. Most of my displacement would have been at a higher velocity than the rest. Okay? So we weight it this way. So what I want you to do is write down this example here, and then we'll walk through it together. Okay? So you can kind of see an example and see what I mean. I'll give you a couple minutes to write it down, and then we'll go through it. All right. So here's what I have to basically understand about these two formulas, okay? This formula, even though it's written like this on your formula sheet and most of the time when you see it, actually means average velocity equals the total displacement over the total time. Okay? That's obviously implied if you're dealing with a trip that has only one section, so it's never written like that. But if you're dealing with a trip like this that has two different parts, it becomes very important to recognize that. The same is true for speed equals distance over time. We're still talking about the total distance over the total time. So here's what we want to do. We want to first write down our givens. Okay, that is, write down all of the numbers and information the question gives us. And I'm going to split that up so that I see the parts of the trip separately. And then have a section for the totals, because obviously that's what I need if I'm going to calculate average velocity and average speed. So in part 1, they tell me the truck travels at 4 meters per second north. So they tell me the velocity. For 12.5 seconds. And then turns and travels 26 meters south. What did they give me there? Okay, it is a vector. Which particular piece of information is that? Velocity, displacement, or time? It's a displacement. It's in meters, right? It traveled 26 meters south. So it's a vector quantity. It's not a distance. It's a displacement. All right, so I'm going to write that here. Displacement is 26 meters south at 16 meters per second. V, D, or T? V. All right, so we need to look at our units so we know what exactly am I being given. Okay, and that would also be south. Okay, they don't outright say that, but because I was displaced south, my velocity has to also be south. All right, so this question wants me to calculate average velocity and average speed, which means I need the total distance, which I don't have, and the total time, which I also don't have. If I'm going to have those two things, I need to know the distance, or sorry, the displacement and the time for both parts. And I don't have that yet, but I can find it, right? So I have V and T for part 1. Could I use those to figure out what the displacement in part 1 is? Yeah, I just have to manipulate V equals D over T for D. Okay, so V equals D over T, we multiply both sides by T, and we're solving for D. All right, so we'll have 4 times 12.5, which is 50. 50 meters north. Okay, how do I know it's north? Because that's what, yeah, that's the direction it said they were going. They're traveling at 4 meters per second north. My displacement's got to be north. Okay, so now I have the displacement and the time for part 1. So almost there. In part 2, I have displacement and velocity, but I don't have time, but that's okay. I can use these two things to get the time for section 2. Right? So time will equal D over V. So I'm just manipulating this like we did a minute ago, multiplying both sides by time, dividing both sides by V. Okay. All right, so T equals D over V, so that's going to be 26 over 16. I don't know what that is off the top of my head. All right, 26 divided by 16. All right, gives me 1.625. So it's going to take 1.625 seconds. Okay. Can I now calculate total displacement and my total time. Okay, all right. So in part 1, I go 50 meters north. In part 2, I go 26 meters south. What's my total displacement? Hmm? 24 meters north, okay? How do we know that? Well, I'm adding them together, but I'm making sure that I recognize one is south and one is north. Okay, basically I'm just subtracting them from each other. Okay, so I'm gonna have 24 meters north, okay? Because basically what we did was go north and then come back 26 meters. Okay, so we end up 24 meters north of where we started. Everybody okay with that idea? Yeah? Okay. Now I got to calculate my total time. Okay? Do I subtract the times or add them? Well, this one I'm going south, right? This one I'm going north. Does it matter? No, unless you're going back in time, okay, which you're not, okay, you never subtract time, okay? You subtract time, it means you're going back in time. So unless you know something I don't about the nature of time and the space-time continuum, okay, you are not going backwards in time. You're never going to subtract time. All right, so 12.5 plus 1.625 is going to give us 14.125, right? I probably shouldn't do math in my head, but I did. Okay, so now I have my total displacement and my total time. Now I can calculate my average velocity, which is what they wanted me to calculate in part A. All right, so average velocity will be 24 meters north divided by 14.125. All right, so 1.7 meters per second. What else do I need to put on that? North, right? It's a vector quantity, right? It's a velocity. 1.7 meters per second north. Okay, so now I've calculated the velocity. Now I need to calculate the speed. So I need the total distance. How do I calculate the total distance? I just add them together, right? Distance is scalar. It doesn't care that one was north and one was south. It just cares how far did I go. Okay, I went 76 meters. That's how far. Okay, 50, then 26, 76 meters in total. Okay, it's scalar, so direction doesn't matter. 76 meters. All right, so now we take average speed is total distance, 76 meters, divided by the total time, still 14.125. Whoop. Don't want a zero on there. All right, so we're looking at 5.4 meters per second. Okay, does this sort of hold up with what I was talking about yesterday where I said displacement's always going to be smaller than distance unless they're equal, okay? But it can never be bigger, and same with speed and velocity. Does it kind of hold up? Displacement and velocity were both smaller because we went forward then backward. Retraced our steps a bit. All right, so you would have done ones like that in Science 10. So if that doesn't look familiar, that's okay. And that's why we're going over it again, but that is something that you would have done. Okay, a two-part V equals D over T course. Questions on how that one worked? Okay, so you have to do a little bit of manipulating, and you got to do a little bit of scalars and vectors to solve a question like this. Anybody still need it? All right, this one, much easier. It's only a single V equals D over T question. There's no two parts to it, okay? And these are actually out of your digital workbook, which is what I want you to work out of for a bit today. Okay, we probably won't spend the whole class on it because I don't think we need to, right? But let's see how we do. So if you recall, okay, your worksheet booklet, okay, is in the classwork tab, and that's where you'll find the questions we're going to work on. Okay, so it's in worksheet packages here, and we're looking at maybe? Nope, that's dynamics. Of course I picked the wrong one. Okay, so they're right there. That's the one we're working on. Answers are on here in bold. Okay, don't worry about question number 2 for now, because sometimes that one, just the wording of it confuses people. So don't worry about number 2, but let's do 1 and 3, 4, 5, 6. Let's say 1 to 7 for now. Okay, 1 to 7 for now, because after that it starts talking about graphs, which we haven't gotten into. All right, so I'm going to give you a few minutes here to work on questions 1 through 7. I don't think that will probably take you very long. If there's trouble, let me know. We can do them on the board together, okay? Or I can come over to your desk and help you. Just put up your hand, okay, and we'll do that. Okay, so. All right, so looking at number 3, this is very much like the one we did just a few minutes ago. Okay, so during a bus trip, a bus travels 11 kilometers with an average velocity of 21 meters per second, then travels 1 kilometer at a smaller velocity of 4.2 meters per second because of construction. Determine the average velocity of the bus for the entire trip. All right, so this is another one where I've got to break it up into part 1 and part 2. And then have my totals over here. Okay, I only need to know the average velocity, so if I'm going to get average velocity, I'm going to need total displacement and total time. Okay, what I have for part 1 is a displacement, but it's in kilometers. I'm given the velocity in meters per second, so I have to make my units match. Okay, there's 1,000 meters in a kilometer, so this is a pretty simple conversion. Okay, not kilometers, 11,000 meters. And that is, actually it shouldn't be velocity, it should be speed, because we don't have any directions. Okay? We actually can't give a velocity on this because we are never told which direction this is going. All right, so we got 11,000 meters, and then we've got a speed, not a velocity, of 21 meters per second. And then in part 2, we've got a speed, even though it says velocity there. I think this used to be a vector question. I took the vectors off and I forgot to change the wording. Okay, 4.2 meters per second and a distance of 1,000 meters because it's 1 kilometer. All right, questions so far? Okay. So I want to have total display or total distance and total time. Well, the total distance I have already. Okay, I've got the distance for each part. I know that the total distance here is going to be 12,000 meters. What I don't have is the total time, because I don't have the time for either section. But that's okay, because I can calculate it using v equals d over t. I've just got to manipulate for t. So t equals d over v. So that'll be 11,000, okay, divided by 21 for part 1. Whoops, missed the one. All right, so we're looking at 523.809. Now, in terms of significant digits, how many of you have heard that term before? Okay, so we have to be mindful of significant digits. I'm keeping all of those decimals. Okay, I'll just go back in my calculator and grab that number and use it again. I'm not going to write them all down, but I'm going to keep them all in the calculator. So 523.8 is all I'm going to write. Seconds. Okay, then I'm going to do the same thing here. T equals d over v. That's going to be 1,000 divided by 4.2. Okay, so 238 point, we'll say 09. I know it rounds up, but that's all I'm going to write for now. 238. Okay, so now I've got those two numbers. Now I can calculate the total time by simply adding those two numbers together, so I know what goes on the bottom here. All right, so we got 761.9 seconds. Okay, again, I'm keeping all the decimals in my calculator. I'm not forgetting about them. I just don't want to take the time to write them all down. Okay. All right, so my average speed, which is all I can calculate here, okay, will be 12,000 meters divided by my answer from the last calculation. Okay, so my average speed here is going to be, we only have two significant digits, 16 meters per second. Okay, if you're not knowing what I mean and what I just did with significant digits, don't worry, I'm going to go over that next week. Okay? All right. That makes sense? Any other ones giving us trouble we need to go over? How many people have done all 7? Okay. I didn't even know that for it.
7.
You're on 7? You want me to do 7?
I just can't remember the formula that needs to be used. I'm pretty sure I know what it is, but I can't remember exactly.
Actually, we're doing this one just like this is just like the one I just did. It's not an acceleration question. I know you're thinking because it's gravity, it's acceleration, but it's a simplified. Yeah, you would be accelerating, but we're saying not. Okay, so I'll give you a few more minutes. Okay, we'll finish those ones up, and I'll go through any other ones that you guys request, and we'll see where we're at for time. Probably won't get any further than that today.